Okay, from 2025 paper, we were left with two more questions there. So almost 12 to 13 marks they have asked in the gate examination, the signals and systems subject alone. Maths is coming for 15 marks and aptitude 50. So this is 43 marks. So if you are attempting the question paper, if you leave these three subjects, 57 only you'll attempt. And minimum 25 is for qualification, some good rank in NIT 35. It's very difficult to get this for only if you are restricting. And in that also you will be leaving digital part, some analog part, some microprocessor part. So it boils down to 45 marks only. So these subjects are very important. Now let's listen here. The continuous time unit impulse signal is applied as an input to an continuous time linear time invariant system. So what does it say? The continuous time unit impulse signal. Okay, so your x of t, your input is your uh, impulse. Okay, this is given. Okay, is applied to a linear time invariant system. Okay, so this is your system. Okay, and your input x of t is equal to lambda of t, impulse signal. The output is observed to be the continue. Okay, output y of t here you are getting as u of t. Okay, this is the meaning of this. Which of the following statement is true? On applying any input signal to S, that is your system, the output signal is always unbounded. That means it is not stable. It is possible to find a bounded input signal which, when applied to this system, results in an unbounded output signal. Every bounded input signal applied to S results in a bounded output signal. Okay, it is not necessary. So this statement itself looks wrong. Or apply any input signal to S, the output signal is always bounded. This is also not correct, right? Why? Remember, signals do not. One more important property here is that signals in itself don't have causality or memory. It is the system. Okay, only system do check the dependence of the input to the output equation. Now, see here. So I got you the first part here. So the first thing is identify the impulse response for an LTI system. So what is given here? The given already I have written there. X of t is your impulse function. Y of t is your this thing unit step function. And so clearly, okay, what in this case your output, okay, output here, output to any this thing system, okay, the system's output h of t is equal to lambda of t, right? So it's quite clear system's output, which is your h of t, happens to be equal to u of t. Okay, so what does basically a Bebo stable system mean? Bebo stable system is bounded output will create bounded input. Now we are clear. If you go back to my previous lecture also, you'll understand from there. Okay, so the given data is your x of t is equal to your impulse function. But originally, what is your impulse function? Originally, your derived impulse function here is saying your x of, okay, x of t, we do star of h of t, right? This is your convolution process. We'll not go into that convolution and all that thing. The derived output from the system here, okay, is basically your unit step function. So this clearly is meaning your h of t is equal to your u of t, the derived output. So you just substitute u of t here and you just check for the bounded input condition, any output signal here, right? Any like if for m dt should give you the result less than infinity. It should be a finite value. It should not like be an exponentially increasing function. This you cannot bound. Okay. So now if you just put the unit step function, I told you the value of this is 1. So infinity minus infinity. So infinity minus infinity will give you 2 infinity. So this value happens to be equal to infinity. It's not less than infinity. That means the impulse response, that is the output of the system, is not, okay, absolutely integrable. Okay. All see the memory, huge memory systems, all, I have told you in the previous lecture also, if you are doing integration from minus infinity to infinity, this is not absolutely integrable, and this is not a Bebo stable system. So one thing is clear, okay, This is not a Bebo stable system. So now basically on applying any input to the signal, if I apply an exponential signal, if I apply a step signal, okay, or any signals are of 100 types, the output signal is always unbounded. It is wrong. Okay, it is not necessary on applying any input signal to the S, the output signal will be always unbounded. Now let's look at the option number B. It is possible to find a bounded input signal, like your unit step signal is a bounded input signal. So which when applied to S, okay, is giving you an unbounded output signal. So your input signal U of t is bounded, and you are applying this, okay, this signal basically, okay, uh, and you are checking for the C. What is the trick that they have used here? The trick they have used here, this signal to is yaar bounded, unit step is bounded na. See, this signal is bounded signal. Okay, the value is always one. So u of t ka value jo bhi hai will be equal to one when t is greater than and equal to zero. Otherwise, this value is zero, right? So in the interval, in the time frame, okay, when the t is greater than and equal to this value is okay, this area you can create. So suppose they write t up to 4, okay, up to this, so you can, but now this signal is bounded, but its integration is not bounded. Minus infinity to infinity u of t dt is unbounded, okay. So that means the signal is bounded, u of t is bounded. So the B option looks correct. It is possible to find a bounded input signal u of t, which when is applied to S results in an unbounded signal. So the option for this would be B. Okay, let's move to the next slide. Let's go to the next question. Okay, so here, yeah, an ideal low pass filter has a frequency response given by this h j omega is equal to 1 0 omega less than equal to 200 pi 0 0 otherwise. Let h of t be the time domain represent, then h naught of 0 is. Very simple. Here, one property, one equation of Fourier transform h of t is equal to 1 by 2 pi minus infinity to infinity h of j omega e j omega t d omega. This phenomena you will apply. This, with this question, with this equation, it will be solved in 1 second. So he's asking you to find h of 0. That means you put the time 0 here. So h of 0 would be equal to 1 by 2 pi. Now minus infinity to infinity, right? He is giving the values of omega. From where to where? He is giving from 200 pi. So less than equal to 200 pi. So this domain here, you can change this basically. This how you can change is h j omega value is 1. Where it is 1? Only for where? Only from C. If it is 0, it is otherwise. If it is less than or equal to 0, less than or equal to 200 pi. So the 200 pi range can vary from minus 200 pi up to 200 pi t. So your integration limit will change from 200 pi to minus 200 pi. That means from minus 200 pi to up to 200 pi, your signal value h j omega here is 1. Okay, so if you just calculate here, so h of 0 is equal to 1 by 2 pi, okay, and up change the limit minus 200 pi here, okay, the h j omega value is 1 and e power j z omega into 0. So e power 0 here it will become, e power 0 is 1, right, d omega. So this value will become 1 over here. So this will become equal to 1 by 2 pi minus 200 pi, and this value is becoming d omega, which will become omega. So d omega becomes omega. So you have 200 pi minus 200 pi and 1 by 2 pi. This is what you have to do, right? So this will become 1 by 2 pi. 200, apply the upper limit, minus the lower limit, 200 pi, right? So this will become 400 pi divided by 2 pi. So this will become 200. So the answer to this would be 200. This was an easier way to do it. Other people, what they are going to do, I'll tell you. In the gate books, what they have mentioned here, I'll show you one more method. Okay. One more method is very complicated. If you want to see, I'll just, for the sake of showing, I'll show you. Okay. So here you'll just look what is there. See, this is your hj omega is equal to 1 by what was the equation? Hj omega was equal to your not 1 by what is that? Yeah, 1 by 2 pi minus infinity to infinity hj omega e power j omega t d omega. Correct? This is the equation. Now in the very same equation, you know the limits, so you just apply the limits. 1 by 2 pi minus 200 pi over here. Hj value is 1. Here ej omega t d omega. Right? So this limit would just apply for here. Outside this boundary, see, minus infinity to infinity if you are moving. So you're moving from minus infinity to infinity, correct? So in the minus infinity to infinity, here let's say minus 200 pi came. Here 200 pi came. So this is the limit where the signal is absolutely integrable. Okay, outside this range, this is zero, right? Hmm? So the range is this. That's why we have just put this value over here. So if you just integrate e power j omega t d omega, so it will become e power j with respect to d omega, right? E power, okay, e power j omega t. So this will become e power j omega divided by j omega, right? E power j omega t divided by j omega. This will become like this. So now let's move to the, yeah, where it is, yeah, here e power j omega, yeah, where, okay, here I've solved. E power j omega t, okay, e power, okay, with respect to omega, so t will be there, right? E power j omega t jt. So this function becomes e power j omega t jt. Okay, these are the limits there. 200 pi minus 200 pi. So this will become e power wherever your omega value is there, you have to substitute 200. Oh, this t value is there. You have to substitute this 200 pi. Okay, because I want to see here. So wherever this omega value, because it's with respect to omega na, so you just substitute this 200 pi. So you just substitute here e power j 200t minus of e power minus j 200 pi t, actually not just t, pi t divided by jt into 1 by 2 pi, correct? So e power j theta minus of e power minus j theta is equal to 2j sine theta. So now the theta value here is this value 200 pi t. So this value will be equal to 2j sine 200 pi t divided by 2 pi. Okay, and jt is also there. So this j goes, correct? So you're left with 2, 2 also goes, 2 goes, 2 goes, correct? So you're left with 200 pi t divided by pi t, correct? Pi t. So this is you are solving for h of 0 value, right? This now I've just taken h of t value over there and I'm just solving for the h of 0 value there. So now you notice here what you do is you have a function like this sine x by x when limit x tends to 0 is equal to 1. So you just bring it in that form. In order to bring it in that form, you have to multiply by 200 and divide this function by 200. Okay, so this will become, yeah, this will become sine, sine is here, sine 200 by t. So this becomes sine x by x form. So this is 200 into 1. So h of 0 value will be again equal to 200. So whether you do this method or you utilize the previous method, right? One and the same thing. Okay. So this is the same thing I've written over here. So you can do like this, or you can directly. Why we are putting this here t0, because we want to calculate this h of 0 value over here. That's the reason I have put. Or directly you do whichever it asks for 2 marks. The best method is the direct method. Okay. So gate is not checking your deep concepts. They're checking how quick you are, how fast you are. That's where I'm lagging. Okay. I was recording it, so I have to stop recording. Or Mhm.